Greetings. Am I sounding okay?
Yep.
So I'm going to talk to you about WorldMap and using GeoNode. WorldMap is a version of GeoNode. Using GeoNode to organize distributed geospatial data and explore a billion spatiotemporal objects. I don't know whether I'm going to get to the billion, but I'm just throwing it up here because it might be relevant for this group. We are building a platform now that will support interactive exploration of a billion geotweets, real-time streamed geotweets. And really the main point here is that the system that I'm going to show you is built on the same thing that the billion system is built on, and so the system scales. So what do I mean by distributed geospatial data? I'm really talking about spatial services, map services. And I'm really talking about the two major open types, OGC and Esri REST. I don't want to get into a question about which is more open. They're both out there and they're both heavily used, and there's petabytes and petabytes of spatial data behind these interfaces. These are hosted by all kinds of organizations, governments, local, state, federal, you name it, businesses, NGOs, universities. Represents lots and lots of data. But as we all know, they're a little tough for the average person to find. They're even tough for a really seasoned GIS professional to find. I would almost say at all. Because this is what I do, and often I'll just have a devil of a time finding an actual endpoint of a server that works so I can do something servicey with it. So there are ways to find data, they're just not good ways to find and bind to it in an open way using systems like GeoNode, or really using systems like any spatial system. I would even go so far as to say we're about in 1995 with the ability to find a web page on a particular topic. That we're at 1995 for geospatial services right now. I don't think that's too much of an exaggeration. Often the best data is outside of your organization. It doesn't matter who you are. You can be Harvard. You can be NGA. You can be the United Nations. You can be anybody. And a lot of the best data, the data you actually really need, to, or at least need to look at, is outside of your organization. So in the context of this secondary cities effort, which I just know a little about, but looks really, really fascinating, it seems like the problem of distributed geospatial and the problem of discovery seem to be especially acute, could be especially acute within this context. And
Just adjust your mic, sorry.
my apologies to Brian Roberts. I cribbed this slide, but I really liked it, and I'm giving him credit. He says one of the critical issues is vertical and horizontal integration, particularly between government systems. In many countries, there are parallel systems. One agency doesn't talk to the other. Nobody knows what anybody else is doing. That happens pretty much everywhere. Add to that this characteristic of, I think, burgeoning urban spaces. They're clustering like crazy. So what scale are you really interested in? Often you're interested down at the detailed city scale of streetscape, but you're often looking at regional patterns as well. And how do you search for data at multiple scales? All right, where does WorldMap fit into this? Well, WorldMap is a version of GeoNode. We've been maintaining it for a while. It's now the largest GeoNode in the world with 17,000 users and 28,000 data layers. It was built to lower barriers for scholars who may not need, who don't necessarily want to or need to know lots about GIS, but want to use geodata in their research. And WorldMap has become one of several major testing grounds for new GeoNode capabilities. If you saw Paulo's talk earlier, you heard him talk about a number of features we're developing. So we received an NEH grant a few years ago to build an open, scalable registry of geospatial map services. Interesting that it was funded by National Endowment for the Humanities. Now that's very interesting to me. Build a UI to support search by time and space, search this data by time and space. Open API to enable any system to find it, not just available within WorldMap, but really something that anybody could build a client to access. Feature level search is also in this proposal, is in this project, and we're working on that now. I don't have anything to show you on that. But for local layers, we can actually dig down at the feature level, and a temporal gazetteer. So we built an alpha version of this search capability that I'm going to show you, this map services search capability. And we built, I think, somewhat of a fairly new sort of front end. You can tell me whether you think it looks new or not. It supports faceting, and I'll describe faceting more later if you're interested. But faceting by geographic space, time, not implemented yet, but coming, subject matter, source, and potentially other dimensions. The back end is a scalable map orchestration system that can scalably harvest from and monitor from virtually unlimited number of distributed servers, developing uptime statistics for everything at the server, service, and layer level, because that's important for search, knowing what, because it's a very ephemeral world of map services. Crowd curation is something we're very interested in, and scalable open API. So a note here, we're calling it, so this piece, which runs kind of behind the scenes, we're calling Hypermap Registry. That's what it's called in GitHub. It can run with WorldMap and GeoNode, or it can run outside. It doesn't need, it's not dependent on them. It could run with any system. It's written in Django. It's Pythonic. It's released on GitHub just a couple months ago, and already the NGA is building on it, which was a really, really nice vote of confidence. We actually had a code sprint last week where we had several developers from their team and our team working together on a few thorny areas. So, I'm going to do a demo. This is alpha, right? This is real alpha. The UI is fairly crude. The back end is also in its early stages, but think more about the back end and what we're doing. And it's scalable. We are using it to create a much bigger spatiotemporal search capability. And with that, let's pop into what, if any of you have ever used WorldMap, this is what it looks like exactly. We haven't changed this part at all, unfortunately. It's really getting old in the tooth. It's quite an old version of GeoNode. And the idea is that once we're finished with this last push on this NEH grant, we will migrate to the latest version of GeoNode, and everything will be great. We're going to push a whole lot of new features, and we'll get some new features from GeoNode that we don't have. If I click on, in typical WorldMap, you click on Create a Map. This takes you into a map composition space where one can add layers, create layers, symbolize layers, save collections of layers, generate, zoomable, embeddable maps that you could plug into your blog, and so on, all kinds of things. This is pretty much the same. This is where it gets different. So when I'm going to click on Add Layers, and what you're going to see is a plugin that we built within WorldMap which points at this registry. So this is the plugin. And what this heat map here is, quite crude, but this is getting refined, is the on-the-fly distribution rendering of 85,000 overlapping bounding boxes. Okay. We can mouse over the heat map, and we can see how many layers are at a given location. Of course, this map is zoomable, as you'll see. We can search by keyword. We can search by source. And source here is, for remote services, it's the domain of the server. So we can actually focus just on a particular server that might have thousands of layers in it. Or if it's a user, if it's a WorldMap user, it's the username. So we can focus in right on a user. This is all sort of evolving, but that's how we're doing it at the moment. This lets us search by a number of types. So everything is searched by default, that is WorldMap layers, which are local layers, and have some characteristics that remote services don't have, like the fact that you can edit them. In theory, you could edit over a service if it was a transactional WFS and blah, blah, blah. But, so here's a breakdown by service type, and we can also search by time. And we didn't want to annoy the geologists, so we decided to just go back to the beginning of the Earth. And we go a couple hundred years into the future because there's a ton of data out there that goes a couple hundred years into the future. I think we stopped at like 300 years in the future because nobody's really talking much beyond that. And we bring back, we always bring back a list that is, we do the best job of ranking that we can. And this is going to evolve and improve over time, and there are many, many ways that this can get better. And I'll go into some of them. Right now, of course, we don't even have a search, so it's a little tricky to rank. Nevertheless, we have ranked, and I'm just showing you the top 200, and that's all the different servers that these are coming from. Some have locks, meaning they're WorldMap layers. The user is not publishing the data yet, so we support the research lifecycle where some people might want to have their data private until it's ready to go out. And then we support this capability where when we mouse over, we do an instant preview. And this instant preview will eventually be for everything. Right now it's working well with most WMSs, some Esri REST, but there's some work going on that will make it work for all Esri services. And so clicking on a layer loads it to the, we call it the cart. So let's just pick a couple layers here, add to the map. And now we're off to the races. This is now we're in typical WorldMap land, and we could save a map and so on. So
Can you download the data here?
so this is a remote service. So these two layers that I just loaded happen to be WorldMap layers. So these are downloadable. Yeah, or most, I should say, most WorldMap layers are downloadable. Most remote services won't be, but some are, and you'll see. So let's do a keyword search. Roads. Roads is useful stuff for secondary cities. Let's zoom in here. And as we zoom, we're filtering by space as well. And we're not just going literally roads. We've got a whole dictionary where we try to be smart about all different kinds of transportation-related things. And we try to be smart about the previews. Let's just go right across the pond here and see what we've got over here. Zoom in a bit. So as we zoom in, we get more detail. I think this is interesting. Here, from a secondary cities perspective, we can see where we have data probably on roads down at the city level. So these, there we go. See, that's rendering right there. I could turn that on. So that, I don't know if it's roads. Let's hope so. Agglomeration. Maybe I zoomed into the wrong place. Oh, anyway. So that's roads. That's strange. Oh, okay. We have a bug where there's a certain scale that is making a request for a heat map that's too high resolution. And all the rendering is happening on the client side to make it very scalable, so it's not backing up on the server. All the heat map renderings on the client. Even though we're looking at 22,000 layers here, this is a heat map of the overlapping, it's also a polygon overlay in a sense, overlapping bounding box of 22,000 layers. Okay, so let's do, just one other. So here's gas. So this is energy-related stuff. And we can look at broad patterns across the world and this is another key, I think, important concept here and thing that we're trying to do with this interface is we're trying to let people quickly see where the data isn't. Because that's one of the toughest things in an exploration system is just knowing where there isn't data so you can go somewhere else. Or knowing where there isn't data on a particular server. And we'll do a search against a particular server, or knowing whether there's data most likely on a particular topic. Now, I wouldn't say that because we've typed gas, we've absolutely definitely gotten everything that could be energy related. We know we definitely have everything that has the word gas in it, and we know we have everything that is in our dictionary, which will grow over time. All right, so let's just zoom in here and see what we got. So as we zoom, we refilter, and we're always, and one of the things we search on, we rank on, is the way that the current data set fits within the map view. So it's not a coincidence that the stuff that shows up fits pretty well out of the 73, fits pretty well with the map and is relevant for that scale. Okay, now I want to show you something else, another capability here. We're going to search for materials on a particular server. So New York Public Library has a wonderful collection of geo-referenced historic scanned maps. This was funded by NEH after all, and we knew that this collection would be valuable, and we also knew that it had dates that were at the metadata level that were input, by the librarians for most layers, and we want to show a system and show the promise of a system that has temporal search. And so here we have a footprint of 3,700 layers. At a glance, we can see, oh, that's where New York Public Library has its data, and that's where it's concentrated. Now, I'm also showing this because I think this could be valuable for thinking about, say, an image collection. This is raster stuff. Imagine a government server that's got, 100,000 satellite images all with dates. You want to sift through it quickly, right? You could if you've got your date and some basic code or description, you could be moving through it, briskly. So let's just, pick a map, add it to our view here, and We can control transparency and things like that here. I won't get into that. Now I want to show you something. Any layer that we bring in here, we can go behind the scenes. Now I'm taking you behind the scenes to Hypermap. So I mentioned this layer orchestration system that drives this user interface. This is the layer page for this layer that's sitting on the New York Public Library site. And so here are all the endpoints for it. Here's some title, name, abstract, date. Date is from metadata. We also have a date miner, which attempts to recognize dates in titles and abstracts, because many, many times it's there, but nobody put it into the metadata. And so if it did say, if it was such a date that we recognize, we would say detected, date detected. And so we distinguish between those. Wherever possible, we get the user to the actual landing page that the data set was on the remote service, to get us out of being in the middle as quickly as possible. Let the hosting organization provide other information, including especially download, right? We don't want to get into the download business, really. Just a note, so I'm going to go now to the main Hypermap the home page, and I am logged in as an admin. It wouldn't be hard to allow, an organization could decide how much of this they wanted to make accessible to non-admins, but this is a summary tracking 16,000 remote map services and a total of 200,000 layers. You only saw 85,000 in the system because we keep doing presentations and we've got all this backlog of services that we've harvested, and we don't want to push it into Solar and risk breaking something. So we just harvested another 150,000 that are just waiting to get loaded. They're already here, so this is in Postgres. Once something's in Postgres, it then, for search optimization, it gets pushed to Solar. We have them broken down by map services here. Let's click on a service. So this is a service called, this is GeoNode. This is the State Department's GeoNode. So there I am. 19 layers on it. And there they are. And those are the reliability numbers. So we're doing uptime checks on them. Let's just click on a random one. And so now we're at the layer level. And let's take a look at, they have very robust projection handling in those State Department layers. They're conforming to some rigorous standard, I think. That was causing us a little time to harvest. We're going to have to do a little right around that for that. But I guess, all right. So let's just see the checks. So this is, we don't have this on a regular check right now, but that's how many times it's been checked. And if we wanted to check it again, I could just check it. There, we just pinged the server, and there we are. We've got another check. So, and all of the checking and all of the harvesting can be optimized on Solar using something called Celery, which is just a nice tasking platform that lets one run multiple concurrent asynchronous processes and farm them out to as many nodes as you want, as many workers. So here's the list of domains that we've harvested so far. This is like about 2% of all the domains that we currently know about. And we list each domain with the number of layers on the domain and the number of services on the domain. And it looks like I'm hanging. Not sure why. Let's see. Go to monitor. Oh, there's our monitor. We can go to our admin. This is the admin Django backend where one can provide a list of endpoints to go and harvest. and then monitor the results, monitor endpoints as they're being harvested. This actually gets you to the solar backend where you can do some testing. Okay, so let's go back here. Right. So there's NYPL. I want to show you that one can also search by service type. So far we've been searching for services across all types, Esri and ArcGIS, Esri and OGC. Let's look for Esri map services. So there's 47,000 Esri map services that we've got in the system so far. We can see where they are, where they're covering. Our map previews are not working yet for most of these, but we do have map previews working for servers like this one, which are tile caches. Let's zoom out here. So there, so some Esri layers which are served up using caches, we can do nice previews on. I'm looking for a particular one that I like to show. Oh, this is cool. World navigation charts. So this is the ONC Army navigation mapping. And Esri's got them loaded all the way down. They start at the 1 to 1 million, and then I believe they go down to, did they jump? No, they do have another service where you get all the way down to the quad sheets, which is nice. So yeah, so basically just to say that OGC and Esri are sort of are both being supported as robustly as possible, with the idea that that this should be a place where any and all great map services can be used and useful work done with them. Again, this is just a plugin, but if somebody could build a client that accesses this registry from QGIS or ArcGIS. NGA is actually, I believe, working on something which is using a more modern, we're kind of stuck for now in this old EXTJS framework, but they're building something using Angular and OpenLayers 3, which is starting to look really nice, which we'll probably be moving toward, or we are moving toward in the coming months. Let's see, what else was I going to go over here? Oh, I wanted to show you, it's kind of fun. Let's do a reset. And so that is searching on the domain for the string geonode. So it's not a perfect way of calling all geonode servers and doing searches across all geonode servers, but it's a start. To do that properly, we probably would want to add a type, which is a server type. We could have Esri servers, we could have geonode servers, we could have, I mean, there are another 10 GIS servers out there that could be part of that. But right now we're just searching for, is geonode in the name of the domain? And let's go in here. And one could imagine, the one nice thing about any of these ecosystems where you have a consistent provider of the server software. So in the case of GeoNode, there's a community around that. In the case of Esri's ArcGIS server, there's a community around that. One can imagine all kinds of advanced capabilities that could be possible when you have development coordinated on the server and on the client, and a common orchestration platform to let things to support discovery, but also the capability of possibly sharing information between servers. Web processing servers are interesting to think about in this context. How to discover web processing services. Once you find them, Josh Lieberman, I don't know if he's here, so he's working on tools for sort of like IDE for web processing services. So for that to really be practical, you might want to have a discovery platform in order to find the web processing services using various criteria that you want to work on. And that's about it for what I wanted to show with WorldMap, hypermap search. How am I doing for time?
Pretty good. We have
Fine.
until 5:15, so
Okay.
time for questions.
Okay.
Anything else?
I'm going to go for questions, and then I can also, if people are interested in what we're calling the BOP, that's the Billion Object platform, I can talk about that. But I'll first, if anybody has any questions on the registry, I'll start with those.
So thanks for the demo. It's always good to see running code just working seamlessly. So the registry connects to other catalogs and does a search, or does it ingest them and keep the metadata local?
So it ingests them, and it loads them all to a fast index in Solr. But a really wonderful characteristic of Lucene and other NoSQL databases, but Lucene is what we're using, is it's very federatable. So it's very easy to imagine multiple, 10 or 20 aggregations, each with millions of layer metadata records in them, all searchable as if it's one. And the user interface would look like this, and it would be just as fast, because you'd have requests going out asynchronously. And Lucene can combine, in fact, we're doing this with the Billion Object platform. That's how we're doing it. We're putting the billion on a bunch of shards, but those shards don't have to be all on the same network. They can be distributed. I don't know if that was more information than you wanted.
Different and interesting.
Okay, but this is all about harvesting and
Harvesting, not remote query. And so you get agreement with whoever you're harvesting, or do you just harvest if you find a catalog you like?
we're just harvesting. So any endpoints we know about, we're just, unless there's something that says don't harvest me. Yeah, they're out there.
There's a bunch more that you could harvest. The group on Earth observations has, several.
So
kinds of
this
catalogs.
is about 1% of the endpoints we know about that we've actually harvested so far. But there are a lot out there. And I would love to talk to you about others that could benefit from being discoverable in something like this. Yeah.
Have you looked at using Google or other crawlers to find those services without having to rely on knowing or?
Yeah. So we've done a couple things. We use Google. There are some special commands you can type in Google to look at contents of URLs. Well, all in URL is the command. And so you can go after signatures, and we did that, and we discovered quite a number that way. Google comes back and says there's something, last I looked, I think it was maybe 600,000. No, actually it was in the millions. It was millions of Esri service endpoints, and it was many hundreds of thousands of OGC. But Google doesn't let you work through them. It cuts you off after about 20 views. It knows you're doing a sort of interesting, powerful thing, just the fact that you're stepping through a bunch of all-in URL requests, it says, okay, that's enough. So we also wrote something in Hadoop, and we went against the common crawl, and we found a large chunk that way. But that's just the beginning. We know that's the beginning because what kind of person puts a URL to a service endpoint in a web page? That's not casual conversation. That's a geek. And so just imagine how many don't make it into a web page. And so that's what, so it'll be important in this system to have a place where it's very easy for people to submit endpoints and get them harvested and added to the system. And of course, the more organizations get into this sort of thing, the more the possibilities come up for sharing or federating, because it's sort of all this common challenge of how do you make public map service data discoverable, which is sort of a no-brainer, I think.
Any other questions? All right then, well, thank you very much for that
Thank you.
presentation. At this point, I think that we are free to have refreshments outside in the lobby. Is that where?